Okay, so today we will be covering the question of momentum. Before we move on to the question, let us recall a couple of things about momentum. First, the momentum is the product of mass and velocity. And secondly, the law of conservation of momentum, which states the momentum before an event is equal to momentum after an event. In this case, the event can be the jumping and the collision or anything. In this scenario, we are given that a girl is standing on the edge of the trolley, and initially the trolley and the girl are at rest, which means their velocity or their momentum is 0. Then the girl jumps backwards, and we have to explain the motion of trolley and the girl using the idea of momentum. So first of all, we must tell what the motion of trolley is. This question is of 4 marks, so we will need to have at least 4 points for our justification. So the motion of trolley, which we can easily predict, is that trolley will move forward. Now, why will this move forward? So to justify your claim, you will need to state the law of conservation of momentum. Conservation of momentum, which basically states that the momentum before jumping is equals to momentum after jumping, right? So this is the law of conservation of momentum. Now we tell that before jumping, the velocity, or we can just say the girl and the trolley were at rest, right? Because the trolley was not moving and the girl was on the edge of the trolley, so the girl was not moving too, and the total momentum before the jumping was 0. The momentum after jumping should also be 0 according to the law of conservation of momentum. So we must say that if the girl jumps backwards, then the trolley will move forward in order to conserve the momentum. So lastly, we will state that the momentum of girl and trolley is equal, but in opposite direction. So if the momentum of the girl is, let's say, P, then the momentum of the trolley should be negative P. And if we add both of them, we get the P and negative P gets cancelled and we get 0, which is the correct answer in our case. Okay, so moving on to the second part, which is, so this part was theoretical. Now this second part is practical part, or we can say numerical. So in order to solve this, we will also use the idea of conservation of momentum. Now here they have stated that the momentum of, they have told you the velocity of the trolley, and they're asking you the velocity of the girl. So we know that the momentum of the trolley and girl is equal, but in opposite direction. So the velocity, so first we state the momentum of trolley. Momentum is denoted by P, so that's why I'm writing it by P. So it is mass times velocity. Let's make it a little bigger. So momentum is the mass times velocity. So we know that the mass of the trolley is 7.5 and the velocity is 1.2, or we can write units. Let's not forget the units, meter per second. Now we calculate the momentum of the trolley, which is 9 kg meter per second. So this is the momentum of trolley. We know that the momentum of the girl is equal to the momentum of the trolley. So the momentum of girl is also equals mass times velocity. Here the mass of the girl is 36 and the velocity we have to find out. So the momentum of the girl is 9 from the momentum of trolley, and the mass of the girl is 36 and times V. Now we need to find V in this equation, so we divide both sides by 36 and we get V is equals to 9 divided by 36, which in our case is V is equals to 0.1/4 or 0.25 meter per second. So this is the velocity of girl. So that's how you solve the question. In this, there was 1 mark to find the question momentum of the trolley. So it was for 1 mark, and 1 mark was for using the correct equation for the velocity, and 1 mark is always for the final answer. So that's how you have to show these steps to get the all 3 marks. So you have to show these steps in order to get 3 marks. Hope this helps. Hope this helps, and thank you.